Hello, I'd like to welcome everyone to today's mini lecture. We're going to work on concentration of solutions, and we've been working on the parts of solutions, which is the solute and the solvent. Now what we're going to do is we're going to look at concentration. Concentration is nothing more than the amount of the solute that's dissolved into a certain volume of the solvent. So as you can see, we have a formula here. The capital M stands for molarity, and that's what we're going to be using to describe the concentration. So molarity is equal to the moles of the solute divided by the liters of the solution. So I have a couple of extra little add-ons here. It says if you're given grams of your solute, then you can use the molar mass of the compound to convert that into the moles. Then it says if you are given milliliters of the solution, then you can keep in mind that there is 1,000 milliliters per 1 liter. So you just move the decimal to the left. So what I would like to do is just work a couple of problems for you. There's not a whole lot of notes other than M molarity is equal to moles, and we usually write it out as a MOLE over liters, and we just leave it at that. So what I'd like to do is look at their first problem. I went ahead and started setting this up for you, but I want to go back through and show you where I'm getting all of my numbers from. It says, suppose we dissolve 23 grams of ammonium chloride, which is the NH4Cl, in enough water to make 145 milliliters of the solution. What is the molarity of the ammonium chloride? So it asked me for molarity, so I went ahead and wrote down molarity is equal to moles over liters. But when I look at this, I am not given the moles. I'm given 23 grams. So I'm going to take this 23 grams of the ammonium chloride, and I'm going to convert that into moles. So I do that by determining the molar mass. So I have one nitrogen over here at 14, 4 hydrogens, 4.04, and then 1 chlorine at 35.5. When I add all of these together, I get 53.54 per 1 mole. So I'm going to go ahead and type that into the calculator. That up so that you can see it. So I got 23 divided by 53.54, and I come up with 0.429. So I'm going to say 0.429. So I'm going to come back over here and say 0.429 moles divided by the number of liters. So I look back up here in my original formula. It says I have 145 milliliters. So I'm going to move this 1, 2, 3. So that'll be 0.145 liters. So whenever I solve for this, I'm going to get 0.429 divided by 0.145, and all of that gives me a total of a molarity of 2.96 molar, and that's what we call it, molar, which is a mole per liter. Alright, so that was the first example problem. I would like to go through and work the second example problem for you. It says, suppose we have a beaker with 175 milliliters of 0.55 molar of solution of HCl. How many moles? So guys, I'm going to do the same thing. My molarity is equal to moles over liters. But this time, I'm going to be solving for the moles. So I just simply get mole on the side of the equation by itself by saying the molarity multiplied by the liters. So you just have to make sure that you keep your M's right. So the capital M is molarity, and your MOL is the moles. So now I just simply say moles is equal to the molarity, which is 0.55 molar and I'm going to multiply that by the by the volume in liters. So I have to convert milliliters to 0.175 liters. So that's going to give me the number of moles, and I'm just going to simply say 0.55 times 0.175 for a total of 0.0963 moles. So that is my final answer. So now I'm going to do the last problem. And in this one it says, suppose we have a solution that has 0.135 molar of NaCl and we need 1.2 moles of NaCl. What would be the volume? So it's still the same thing. Molarity is equal to moles divided by liters. This time they're actually asking me to find the volume in liters. So I'm going to rearrange this and say that a liter is going to be equal to a mole divided by a molarity. So my number of liters, I'm going to go ahead and substitute it in, is the number of moles, 1.2 moles, divided by 0.135 molar. So our liters is going to be 1.2 divided by 0.135, and that gives us 0.889. So guys, this is in liters. I could very easily simply say, convert that over to milliliters, and if I did that, that would be 889 milliliters. I just moved my decimal 3 places to the right. All right, so with that being said, I have just shown you how to manipulate the formula molarity is equal to moles over liter and solve for either of the 3 variables. Now what I would like for you to do is to continue and do practice problems 1 through 4, which is at the bottom of this page. So thank you, and I hope that helps.